This question is almost the most simplest one in the commission. So may you do it now? I'll give you maybe 2 or 3 minutes. I think that should be enough. For those equation of motion, you should memorize them. So and then should not or you look it for right now from your notes, okay? But I'm not repeating them now. Uh, June, you get it wrong. No. You all get it wrong. So it accelerates from west at the same uniform weight. So that means it has a constant acceleration. So may you let me know which formula you're going to use? So may you let me know which formula you're going to use? Which one? Which one? So which formula do you use to solve this question? Or you are not using any formula? You just look at it, oh, double the distance. So that means it's moving twice as fast. Hello, hello. Anyone can answer me my question. Yeah, B is the answer. So for this one, you need to use v squared equal to u squared plus 2as. So the question asks what the question compares the final velocity. So that is the u. Initial at rest, that means the u is 0. We use this formula because we need to compare the v. We have the u. We know that the acceleration is the same, and then we know about the relation between the distance s. Okay, and then 2a is a constant. So that means you can say that the v squared is proportional to s. So if s is double, v squared is double. Okay, v squared is double, not v is double. Then v will be square root 2. The ratio of the v will be square root 2. You just take the square root of v squared. That is the square root 2. Then that means the answer is B for boy. Okay. And then, so let's have a look at another question. Uh, so this is also an easy question. This one, so just give you a few minutes. I think 2 minutes should be more than enough. So just try one for 1 minute, and then we go on. Okay, so let's continue. It's always better for you to draw a diagram when you are doing the question. So the rocket is launched vertically upward. I'm not sure if the answer is B for ball. I think the answer is B for ball. So and then the acceleration is 19.6. Actually, this 19.6 has some special meaning. It just means the A equal to G. The acceleration equal to 2G. And then by accident, the engine is suddenly shut off for 10 seconds after launch. And it's suddenly shut off 10 seconds after launch. So that means it will be uh, it takes 10 seconds for it to go to the highest point. And then after the 10 seconds, and then remember, just after the engine is shut off, the object is still moving. Is the object still have some velocity upwards? It's not. Let's say for your car, when your engine is just shut off, it doesn't mean that the car will be stopped instantaneously, is it? So and then the object will still moving upwards, and then after some time it fall. So I need to separate the motion in two parts. The first part, it has the acceleration upwards, u2g, and then after the engine is shut off, and then the acceleration will be downwards, and then equal g. And I also need to let the direction of the motion more carefully. So let's say if I let the direction upwards to be positive, Eh? Albion, he left. Okay, let's say I let the upward motion to be positive. I keep using 2g to simplify our calculation. Okay, otherwise your number will be very ugly. So what I need to find. So I need to find the time for the astronaut. The time from at this point to this point. Okay, and then just minus three. Then you can get your answer. So then we need to find this time. So to find this time, you need the displacement, is it? So you need to think about you need the displacement, and then you need to know the initial speed. You know the acceleration already, okay? You know the acceleration already, and you're going to find time. So that means you are going to use the equation that is s equal to ut plus half at squared. And but right now you don't have the s and you don't have the u, but you can find the s and u from the first part of motion. Is that from the red part of motion? So to find the displacement, and then you can use for the red part of the motion, you know the initial velocity is zero, and then you have the acceleration is 2g, and then you want to find s, and you know the time is 10, and then you can use two equations to find s and v respectively. To find the s, you are still going to use the s equal to ut plus half at squared. You get 100g. To find the v, just u plus at. Okay. So the u is upwards. Okay. So you substitute to be 20g here, and then the acceleration of uh, the green part of the motion is negative g downwards. Because it's downwards, so I'll take it to be negative. The displacement, be aware that the magnitude of the displacement is 100g, but it's downwards. It is a downward motion, so you need to take it to be negative 100g. So and then you solve the equation. For the time you get two solutions. One is the negative value, but you need to reject that solution. Another one is positive value. I'm not sure what will get. So let me check on my calculator. So let me repeat this equation. So one of the time you get is 44.5 seconds. Is it? Then you need to minus 3, okay? You need to minus 3. So your answer should be 41.5 seconds. Not minus 10, because it's after ejection. After ejection. So that means it's starting from this point and then to the end point. How much time does will the astronaut have to be ejected? And just 3 seconds before it hit the ground. So this is the lah. When you go back, okay, after this lesson, you need to do this one. Okay, this one is really a very similar question. Okay, it's really similar. Okay, you can see the scenario are almost the same. So you do it by yourself at home, and then we are going to look at another question. This one, constant acceleration with zero initial speed. So what does mean by first second? The first second means the time interval from 0 to 1, okay? Fourth second, it means from 3 seconds to 4. Now, this one, let you to do it for 2 minutes, just 2 minutes, okay? You have the initial velocity and you know the displacement, you know the time, you can find the acceleration, and then you can find the distance travel from the time 3 to 4 seconds. Yeah, just uh 2 minutes. Okay. Uh, so let's say this angle is theta to the horizontal, and then the acceleration of B will be ag sine theta. That's it. The acceleration of G is obviously the acceleration of A is obviously G downwards. Then we are going to compare the time between A and B. So to compare these two, first of all, we need to know about the relation between the displacement of these two, is it? And you know that A is the diameter of the circle. And then we have talked about this theory before. So that is the angle in semicircle. So this is a right angle. This is a right angle. And then, so let's say the distance between A and C is 2r. There's 2 radius. This angle is 90 degree minus theta. The length of AB will be, the length of BC will be 2r cosine 90 degree minus theta. So that is 2r sine theta. Okay. And then let's find the time for the part of AC. So we know the U is 0. We have the acceleration. So as we are using S0 ut plus half AT squared. Okay, you get the time to be 4r over g square root. Then for the path of BC, the displacement is 2r sine theta. The acceleration is g sine theta. Then obviously you can see that the time is still the same. So that's why you say that these two rings will spend the same time to reach the point C. So therefore the answer is C for cat. Then let's have a look at another common question like this one. Now it's fine if you right now if you can not do any of it, maybe let me give you some DSC exercise first so you can be familiar with those exercises first before you go on to the Olympic level. But uh, let me still let's have a look at this one. The maximum acceleration and deceleration of the train is A1 and A2. A and B are two stations on the long track railway at a distance s apart. T to C where the train is at rest at A. Find the minimum value of T when the train stops at point B. If I draw the scenario, if you draw the diagram with something look like this one, the train keep on accelerate. And then because it want to be stopped when it at point B, so it need to decelerate here. And if I draw the uh, velocity time graph, the graph will look like this one. First of all, it accelerates and then decelerate. Okay, and then we are going to find this time. And what you know about it is the distance is s apart. So we talk about this. The area of the VT graph is the displacement. So that means this area is the s. And then the slope or the gradient of the VT graph is the acceleration. So that means this gradient is A1 and this gradient is A2 or you say negative A2. Now the hint for you is to separate the time into two parts. So let's say this is T1, this is T2. Uh, if you're given the graph, you need you may not need any equation of motion to solve this question. Actually, in this question, you just need to look at the graph. You need to know about the meaning of gradient and also the area. Then may you set up all the equation that you can do, and then relating all the quantities. That means S, A1, A2, T1, and T2. And then finally, what you need to do is to find the time T. So that is T1 plus T2, obviously. Then I'll just give you some time to write down the formulas, okay? Write down the formulas. I just want to see if you can write down all the formulas that are needed. So just 2 minutes. After you write it, you can either type it in the Zoom or you WhatsApp me. So you can see there two. You can this big triangle can be separated into two right angle triangles. The one in the left hand side on the left hand side, it has a height. You can say that it has a height that is A1 times T1. The one on the right hand side can say it has the height that is A2 times T2. This one, this is the height. You know the meaning of gradient. That is change in y over change in x. And then to find the area of this total triangle, the large triangle, that is S equal to half the height A1 T1, or you can use A2 T2, that's totally fine, plus T1 plus T2. So these are all the formula that's needed to solve this question. Uh, I would like you to try, okay, to see if you can find T1 plus T2. Okay, to find T1 plus T2. Uh, in terms of S, A1, and A2. So I'll give you 3 or 4 minutes. I think that should be enough. Uh, like giving you the equation, the remaining works is just mathematics, your algebra. So may you do it and then send me your work. So let me see how well you do in math. So all of you send me your steps in WhatsApp. Okay.